Is 10.2, and we're in Algebra 1, and we are at the end of April already. And we're going to be doing square root stuff. So we're going to start off with the most basic. I'm going to make a list of them here for you. And any of them that you can answer, please do so before I tell you what they are. Put marker on. Okay, so 10. That is correct. So what happened in all of those is he found the number that multiplied and gave you the number inside the square root. So 7 times 7 is 49. This square root sign is asking a question. It's a physical representation of a question. The question that it's asking is, what number times itself will give you this number that's inside here? But instead of writing that sentence out, they came up with a symbol for it. This is the symbol for that question. So instead of writing that question out, going, what number times itself will give you 9? Instead of writing that out, there's a symbol for it. So this is the symbol, the square root symbol. We have all these. All of the numbers that I listed are perfect squares. Perfect squares, if you kind of recognize them really quickly, that will help you in what we're about to do. Perfect squares, if you start off with it, 1 times 1, 1 happens to be a perfect square, so 1. Then 2 times 2 would make a 4. 3 times 3 would be a 9. 4 times 4 is 16. 5 times 5 is 25. Hopefully you're starting to pick up one more pattern here. 7 times 7, 8 times 8, 64. And yes, you do want to list these. Because if you don't have these memorized, you're going to want to have a list of them across your paper. So what did I leave off with? 8 times 8. So 9 times 9, 10 times 10. And I don't really see usually anything beyond here happening, so I'm going to put dot, dot, dot. That 1 is lovely, but I'm going to put a box around it and kind of put a don't use. It is a perfect square, but with what we're about to do, it's useless. It doesn't do us any good to even have it there. I'm going to go to my next screen. Colors on you. That's what we're doing. We are going to do the square root of 40 instead. Now, the square root of 40, if you notice, 40 is not in our, I almost listed my wrong numbers. If you look at your numbers that are perfect squares, then I'm going to stop right there, keep going. If I look at these, 40 is not one of them. If you put 40 in your calculator right now, do that and press the square root button, and somebody raise your hand and tell me what you get. 6.32. This is not what we're doing today. I am very proud of everyone that has a calculator and that can press those buttons. And that pressing of those buttons is actually very useful, but it's not the skill that you're learning today. The skill that you're learning today is how to break this down so that you don't round your answer. This is a rounded answer. That has been rounded. That is not the exact answer. When you get into real mathematics, you can't round everything. When you round stuff, you change the answer. If I'm building computers, I think most of you realize that the parts in the computer are extremely tiny and that these measurements way out to the 10,000th place matter. You can't be rounding and the math to come out so things fit together, especially when you get very, very, very teeny, and or when you're building things very large like skyscrapers and bridges. The numbers have to be fairly accurate. So for the math to work, later on, we need to come up with an accurate answer here. So this is my way. I'm going to pause this. What you do is you look at your perfect squares. Does anybody see a number up here that would go into 40 evenly? Do any of these numbers go into 40 evenly? 4. You come down here and you go 4 times 10. Because 4 times 10 is 40. And keep it in your square root. It'll still be in the square root. The reason you do that, these perfect squares are the only numbers in the universe that can get out of a square root sign without being rounded. These are every other number that gets out of a square root will end up turning into a decimal. These are the only ones. These perfect squares are the only ones that can get out of a square root symbol. Oops, let's just see why. without getting rounded. You don't want things to be rounded. What's going to happen is now that I've written it this way, what is the square root of the 4, McKenna? Right, so this is going to come out here as a 2 and leave the poor little 10 inside. That is your final answer. What we've done is we've simplified this down to, we got something else, but the number that was left inside, if we were to try to get it out, it would come out as a rounded decimal. We don't want to do that. You can actually add with these, subtract with these, do FOILing with these, and you'll keep your answer accurate. If we were to pull it out as a decimal, we will have rounded it, and then it will get rounded again later. So this is an accurate answer. So let's try another one. 90, because 9 is a pretty straightforward one. So you look at your list of perfect squares. Look here. Look at this list. I'm going to highlight them. And find one that will go into 90 evenly. Try which one. So don't start with the big ones, start with the little ones. Always start with 4 and then try 9 and work your way that way. Yep, it'll be 9. And most of you know that 9 times 10 is 90, so we're going to write that down. If you did not know that, you can use a calculator. You can go and just keep dividing until you hit something that works. But you're only going to use these numbers. You don't use 2, you don't use 10, you don't use 15, you only use these. These are the only ones you have to check. And there's only a couple that are small. Think about it. I mean, there's not a lot of choices here. So the 9 will come out as what, Drew? What's the square root of 9? Yeah, so the 3 will come out, and the 10 gets left inside. There's your answer. So let's do another one. Do 200. Look at your perfect squares, which I did not keep going. So 49, you should have more on your paper. 49, that was 7. There's my 8. There's my 9. There's my 10. There's my 11. There. You can list more of them. I had some of them listed. Going. So which one of these will go into 200 evenly? Now, depending on which one you use, the problem will be easier or harder. I don't know about you, but 4 works, 25 works, and 100 works. All 3 of those work. You need to pick one of them. I would recommend picking the bigger one. You'll have less work. If you pick one of the smaller ones, that's fine. I'll show you what you have to do about that. So what do you think, Taylor? Right, so 100 times 2. Please notice I'm still in the square root symbol here. What is the square root of 100, Bowen? All right, so I bring the 10 out, leaving the 2 inside. That would have been the quickest way to do this problem. If you did not recognize that the 200 was divisible by 100, this is what you might have done instead. Let's pretend you figured out that 4 works. So this is what you have on your paper. You have 4 times 50, which is right. 4 times 50 is 200. Well, what is the square root of 4, Nick? So bring the 2 out. So this is where you're not finished yet. You would still have to break down the 50, so you have to go back up to your list and find another number that would go into 50. And what you should find is 25. 25 is a perfect square times 2. 25 is on the list. If you look at the list, at the top here, see how the 25 is on the list? So that 25 is going to help us do this problem. So now the square root of 25 is what, Bowen? Right. So the 2 will stay there, the 5 will come out with it, that 5 is there, and that poor little 2 gets left. Look what you get, 10, 2, just like we did. Which one was easier? The first one. All right? So if you can find the largest one that works and use it, that's better. But if you can't, you can work through it using smaller numbers. It just takes longer. Here's another one.